In this video, we're going to explore the law of cosines. So the law of cosines will help us solve a triangle, which means find the remaining parts for a triangle that's either side, angle, side, or side, side, side. So side, side, side is pretty easy to see. All we have are the three sides, and our goal is to figure out what are the angles that we're missing. With side, angle, side, notice that you've got the side and this side, and they are connected, and you're missing the angle, or excuse me, you have the angle between those two sides. So you got two sides that are connected, and you know the angle between. And that's what side, angle, side is. So as long as we have a triangle that's in one of those two forms, then we can use law of cosines to help us solve that. So here's our formula for law of cosines. So we've got, maybe we're looking for side C, and we know side A, side B, and angle C. And then we can come up with other iterations of that. So let's look at a couple of examples. Let's start with this one. So this is a side, angle, side problem because I have two sides that are connected and I have the angle between. So it lets us know we need to use law of cosines. So let's label what we have. So if this is A, then this is angle A because it's directly across. B means this is side B. Angle C here means this is going to be side C. So I need to use the iteration that has those three components in it. Let me see if I can get everything on the same page so you can see things clearly. So we're going to use this iteration here. A squared equals B squared plus C squared minus 2BC cosine A. So let's substitute in what we know. So B squared plus C squared minus 2BC cosine of A. I'm going to simplify this before I plug it into Desmos or a calculator. So we're going to have 9 plus 16 minus 24 cosine of 30 degrees. 9 plus 16 is 25 minus 24 cosine of 30 degrees. And cosine of 30 degrees is one of the ones that's on the unit circle. So we could get an exact value, but I want to show you how to use Desmos to find that. So now we're going to take the square root to get A by itself. Remember, we want A, not A squared. And then I'm going to go over to Desmos, and I'm going to type that in. So I need square root of 25 minus 24 and we need to make sure we're in degree mode. So I'm going to go to this and see I am in degree mode. So there's my approximated side. So A is approximately equal to 2.05. So now we've got to figure out B and C. So let's figure out C. We could use law of cosines for that too. And using this, our goal would be to solve for C. So let's do that. So we've got C squared equals A squared plus B squared minus 2AB cosine of C. So I've got 16 equals 2.05 squared plus 9 squared, sorry, plus 3 squared, which is 9, minus 2AB cosine of C. Remember, we're looking for angle C. So I'm going to simplify all this. So I got to get this guy by itself, which means I need to move everything else. So I'm going to subtract the 2.05 squared, and I'm going to subtract the 3 squared, which is 9. So I'm going to type all that stuff into a calculator. So 16 minus 2.05 squared minus 9 is 2.7975. And negative 2 times 2.05 times 3 is a negative 12.3. So let's divide everything by the negative 12.3. And then let's take the inverse cosine of both sides. So 2.7975 divided by negative 12.3 is not a very nice number. I'm going to use quite a few decimal places so I can get a better estimate for C. And then we can use Desmos to come up with this. So in Desmos, to do inverse trig, remember we have to use arc cosine. Arc cosine is the same thing as inverse cosine. And then we've got negative 0.227439. And we need to make sure that we are in degrees. So we need to go here and look at degrees. And our angle will be 103.15. So this is about 103.15. So then to find the remaining angle, remember everything adds up to 180 for a triangle. So we take 180 and we're going to subtract the 30 degrees for angle A and subtract the 103.15 for angle B. So 180 minus 30 minus 103.15 will give us 46.85. Angle B. So we have solved this triangle by finding the remaining pieces that we needed.